Hello everyone, I've got noon Central Time, so we'll go ahead and get going with our May 2021 NHWC webinar. Just a reminder that this webinar will be recorded and it'll be loaded to our YouTube channel at the end, so if you have to jump off for any reason, we'll send an email out with the link to the YouTube channel with the certificate after the webinar. Hopefully it doesn't take a month. I do have the certificate already ready for this one, so won't be a month when you get that. Reminder that we are going to keep everyone muted for the entirety of the webinar, so if you have questions throughout the chat, go ahead and plug them into the chat box and I'll monitor the questions. If it's something that's immediate like audio issues, I'll try to chat back with you during the webinar. But if it's something that's technical for our speaker, I'll wait till the end and I'll read your question off and let Ryan answer it. So I have some preliminary items I'd like to cover first before we get going with our speaker. So I'll go through those pretty quick. Number one is the question, are you on our mailing list? We've been having issues with our mailing list lately, and so we have several members and non-members that aren't getting emails. We have about 1,300 bad emails in our database right now. So if you're not getting those emails, it means you're missing out on some good quality content that you might want to be seeing. The main and probably most important thing is our quarterly newsletter. So the newsletter is free for all of our members and non-members. Our editor, Brian Iserman, and our graphic designer, Lee, have been really working hard on upgrading the look and feel of the newsletter and reaching out for really good content. There's articles, interviews, news, and all sorts of stuff in there. So if you haven't seen those in your email, that probably means that you're not on our mailing list. In addition to those, there are numerous announcements that come out, whether it's the monthly webinar or news about our workshops or our conferences. Those all come out from our mailing list. So there's a couple ways for you to make sure that you are on our mailing list. Number one, just go straight to our website. Go up to the very upper left-hand corner of hydrologicwarning.org and click the Add Me to Your Mailing List button. If you're a member, you can go to hydrologicwarning.org, and in the upper right, you click the member login button. It'll ask you to enter your username and password. If you can't remember your password, there's a way that you can retrieve that password. But if you log in, you're able to mouse over your name. You can see my name up there. Just make sure that all of your contact information there is complete. As I mentioned, if you're a non-member, go to hydrologicwarning.org, go up to the upper left-hand corner, and click the Add Me to Your Mailing List button. What that'll do is it'll bring up a contact sheet for you to enter your information. So at the very minimum, we need your first name and last name and an email address so you can be on the mailing list, right? Now, if you do all that, or if you're a member already and you're still not receiving emails from us, there are some tests that I can run. There's some ways that we can try to fix that. So just shoot me an email directly at vicepresident@hydrologicwarning.org, and I'll try to fix whatever issues we're having. So we're really trying to get that email list up to date, make sure that y'all are getting all the information from us and you're aware of all the events that are going on. So with that, we'll transition to our speaker today. Our speaker is Ryan Guerrero from Intellisense. He's going to talk about quote unquote other data collection, and I'm sure he'll give us a feel for what other data collection is during his presentation. With that, I'm going to change presenters over to Ryan. Oh, I can see you, Ryan. Let's see here. So you are sharing webcam, and you should be able to now share your slides.
Okay, great. Let's see here.
I'm gonna make sure.
Is that showing my screen now then?
Yes, sir. We can see your screen.
Okay,
and
great.
we can see your webcam. I'll let you take it away.
Okay, thank you very much. First off, thanks everybody for attending, and I hope that this is very informative for you. I also need to ahead of time apologize if there's any technical difficulties throughout it. I'm coming to you live from a hotel room in Virginia, so hopefully it all works out well. All right, so other measurements. So there's lots of other measurements, other data that we can pull in. We've been recently blessed to hear from a number of people on the types of measurements we can make from stage to rain, and now we're looking at other types. Now to go through all of these would take much more than the hour we're allotted. So I kind of tried to focus on maybe just two that I felt were more utilized by a wide variety of people and not so focused into some of the weeds. And those two I'll be covering are cameras and soil moisture. Cameras are used in a very large variety of different projects for different purposes, and soil moisture is becoming one of the main requests that at least I see in terms of added features to the sensor set. So jumping into soil moisture, some of the basic types we have laid out here. There's two different general types. There's single depth probes and multi-depth probes. On the far left, you see there's a solid state sensor. The way this sensor works is by exciting a current and measuring the resistive nature of the element inside the sensor as you excite a current, and you can measure the voltage drop that's across that resistor that's exposed to elements and changes depending on how much water is in the area. So that's one way of making a quick measurement. Another is capacitive or frequency response. And you'll see that these are pretty prominent throughout soil moisture probes in the industry. They'll actually send out a signal that has a frequency, and they'll measure the frequency shift from one probe tine to the other. And that shift indicates how much water capacity is in the soil. So another really cool way of doing things. Then we get into multi-depth probes, and there's kind of one real big distinction between those two outside of the probe types. These are basically single depth probes, but throughout a multiple, or a stacked multiple to give you a multi-probe. So the one you see there in white is a multi-use multi-probe. So it's very easy to install, very easy to uninstall in order to transfer it to a different location if you need to. It does utilize the same capacitive capabilities as the single depth probe. We also have more of a static multi-purpose or multi-probe. This one actually operates under a TDR, which is measuring time rather than frequency in the response to the soil around it. This is obtained by, or this probe is designed to drill a hole into the ground, and then you actually screw the probe down into that hole. And it becomes less desired for a continual reinstallation of the probe, and more of a, we kind of know where this is going and where we want to use it. But has a much better contact with the surrounding undisturbed soil. So let's get into some of the basics in installation on these probes. So you see off to the left, orientation is key. It's not that you can't install these things vertically, but if you imagine the small tines on this being in just a few inches, if you try to stick this thing in vertically, all you're going to get is a little bit of the grass area and slight depth on the just the skin of the surface of the dirt, and then it averages across those tines, and so you're going to get a summary average of the vertical response there. If you put them in horizontally, you're actually averaging at a certain point, and you can put them at different intervals throughout the soil. I'll kind of explain here as we go. So the way these work, you dig a hole, and then you start to insert probes one by one. And as you insert those probes, you begin to backfill. And you'll backfill those until you're completely underground. You run your wires out to your data logger, and you begin to make measurements. Now, the one thing to note is that there is a lot of disturbed soil in these measurement types, trying to make sure that the soil that you're inserting the tines into doesn't move, that it provides a good contact with each of the tines, and also that the tines don't bend away or towards each other. The measurement is either time or frequency shift, and is based upon a certain geometry of the tines in their relation to each other. So there's oftentimes an insertion tool or something that can help guide those tines into the soil, but it's definitely something you would need to consider when installing these. The multi-probes have come a different direction, and because they already make these horizontal measurements at each location, they can be installed vertically. The one on the left, you see in the dirt, is kind of the more traditional style of making these soil measurements with the multi-use probe. Now, one thing to note is that the auger shape and the probe themselves really make a difference on how you can utilize the measurements within this. Oftentimes, a very pointy auger is used to drill out the initial hole for these soil moisture probes, and you'll notice that the end of these probes is basically the bottom of what looks like a PVC pipe. So what this lends to is the ability of water to creep down the side of this probe and begin to fill up the vacancy or the hole that's produced by the auger itself. So you can actually end up, if these are poorly installed, with a probe that has water completely engulfed around it and is really causing poor measurements. So or other types like the corkscrew type that you see here allow you to make a hole that is pretty close to the exact symmetry of the probe itself, and then as it screws down in, the hole is slightly smaller than the probe, and so they kind of act like your normal everyday hardware screw. If you've ever drilled a pilot hole and then screwed a screw down in, it holds very well and makes contact with the soil around it. Again, it's very tight and kind of a little effort to put it in, so they're not always geared for. I mean, maybe you get 2-3 uses in different locations with the same one, but over and over again, it's not designed to be a constant replacement in different location. Okay, well, we are camera basics. I'm actually not going to go into these type of camera basics. That's just a joke. But camera basics. Cameras have much more involved, so it kind of ran through soil moisture because there's not a whole lot to learn there. But cameras, we have 3 different areas we really need to focus on when considering cameras. So there's some basic features, whether or not it has PTZ or pan tilt zoom, whether or not it's IR, so can it take daytime or nighttime images, what kind of resolution are we looking for, and then the comms piece to it. So with cameras, oftentimes you'll have the smart network cameras that allow control, direct to IP connection, power over Ethernet, and you'll have your simple serial data type cameras. oftentimes, you can look at these as not only the more expensive and cheaper option or cheaper options, but also the more power hungry versus the more power conservative items. So one thing to understand when you're actually looking at these cameras is really understanding how your network works before entertaining certain camera options. Does your system have hardwired AC mains or Ethernet? Can it be powered to use very large consumptions of power? And then, and to be honest, with enough solar panels and enough batteries, you could run any of these cameras, even on a remote network, but it's typically not feasible for most of your remote sites. So these wired would go then to some service portal directly via an IP connection, and then out to some visualization web page. Your remote networks, you can think of either cellular, Iridium, Alert2, all the networks that you're traditionally used to dealing with. I think a majority of people on this line deal more on the remote network side. And then that's transmitted to either a receiver, like an Alert2 receiver tower, or a cellular tower. It could also be replaced by an Iridium satellite there. And then again, sent to a service portal of some sort, and then out to a web page visualization. The main thing to take away here is what kind of power and what kind of communications are you using. So as we get into cameras, these features of pan, tilt, zoom is basically, can you move from left to right, and can you move up and down, just tilt, and can you zoom in on a desired area. So typically these are done with wired stations because they have a much higher power consumption. More data is also being sent to and from, because you have controls that should be sent to control the pan, tilt, zoom. So you'll have a longer time to transmit during transmissions, which can either mean more money if you're on a paid for telemetry, or longer latency if you're on like an Alert2 type slot that you need to increase to a much larger time period in order to get those controls and those images sent. So they're a really great site. If you need really good for a site that you really need to see more of the area. I've seen some where we're able to see the pond, retention pond that they have, and also some of the gates and areas that they're looking at downstream from their retention pond. So being able to pan, tilt, and zoom in that area was highly effective for the customer. Now, let's see, then we also have the night vision. So again, this produces higher power consumption, typically again on wired stations. One of the key things here is most of your events happen at night or in low light. So really one thing you're going to want to consider if you have the power availability, because you get a triggered event. This says there's a lot of water and we have a flood of some sort. If you want to see kind of the actual damage that's causing, you're going to need some type of night vision. All right, so for simple camera features, obviously they're low power. For those more remote locations, there's less data being sent. So there's a shorter time to transmit, making it more cost effective if cost is a problem for utilizing cellular or other types of transmissions. Also that the latency will be much lower than a higher definition pan, tilt, zoom or IR camera. Now, the one thing that's really we're going to go into here in a second is the need for sighting these types of cameras. There is no pan, tilt, zoom, so when on site, they need to be focused at what you're looking at, be sighted in well. The area around it needs to be considered before you can just walk away from the site during installation. So on that note, these are just some blown up thumbnails from cameras that are used in monitoring flood situations. You can tell that on the first initial install, the site on the right or site on the left looked amazing. They were able to see what they wanted to, which is just the current water height. But come springtime, foliage comes in, and there's nothing we can do about looking at anything useful here. So another thing that I've seen in the past is I had a customer that decided they wanted to see what the weather was like, and so they decided they would point a camera directly in the air, and what really ended up happening is this is kind of the best shot we could possibly find off of this system, because usually when it was sunny, the light was so intense in exposure, all you'd see was just direct white. And the only time you could see anything is when there was clouds. So they weren't super happy, but they weren't overly dissatisfied either, because they could at least say it was white or gray. They were happy with it, so I was happy with it. But another thing, not checking. If you go to a site install, you just throw the camera, you think you've kind of got it, because I had a guy installing say that he just puts a pencil up against the camera so he can see where the lens is pointing to, and where that pencil's pointing to away from the camera. I know I don't have to actually log on to the system and see. We got back to the office, and one of the systems had installed the camera upside down. So just turn the unit on, get onto the unit, check the camera image, make sure it's sighted properly before leaving the install. This is a picture of kind of a ideal installation for sighting in a simple camera. There's a lot of open area. The grass does get pretty tall there, but we've positioned the camera to be way out of the reach of the grasses that grow, and we can see kind of upstream. We're not looking just at a cross section, because once we do a cross section, inevitably there's going to be something in the way of one part of the river or another. So might possibly be like the pictures we saw here. So the next thing to consider with cameras is the resolution of your camera, and this is true for both the pan, tilt, zoom, network cameras, and also the simple cameras. So what's your application? What are you trying to find? Are you trying to see the waterway itself and how it's behaving with the embankments around it? Are you trying to see smaller details like ticks on a staff gauge? Or are you trying to view how much debris is kind of going through the river during snapshots? And that's going to determine kind of what camera image you're looking to get. But everybody would want to say, well, okay, well then I'll just buy the 1080p camera for all of my installations. And there's a few things that will deter you from doing just that. So today's world, we're all familiar with how great cameras are in our cell phones. And I think that's become kind of the standard for taking images. Everybody wants the 12 megapixel cameras on all of their imagery. Unfortunately, the cameras I've seen and dealt with in flood are more on the megapixel sizes listed there on the left. So 160 by 120, it's almost 2/100ths of a megapixel. So we're not going for that, because it is determined by the amount of bandwidth and about the amount of bits that we're trying to send here. When you consider the type of communication that you're using. It often comes down to how many bits and bytes can you send via that communication protocol. And am I holding up the rest of the network when I have to send those bytes and bits? So with Alert 2, in mode 2 on the configurable FEC, about a 160 by 120 JPEG would take about 3 seconds. Now that means you have to have a slot available within your TDMA that would allow for 3 seconds and hold up the entire segment, at least, of that network for that 3 seconds. When you get into IoT, you get into LTE-M, also a very slow protocol. We often send a 640 by 480. It takes about a minute to 2 minutes, depending on the peak performance of the cellular network at that point. But you're not holding up any other devices on the network. So you can allot for a much longer time frame without any hold up to the rest of your network. And then as you go into LTE, Cat 1, Cat 4, you begin to send much bigger files at a much faster rate. But the pricing becomes quite a bit more expensive at that rate. And so often think of the bandwidth for these communication protocols is when I'm driving down in LA and can't move anywhere because there's too many cars. If we could open up more lanes, we could potentially move more cars through. And a lot of these protocols, like the LTE-M, don't allow for very high bandwidth. Now, we're typically not sending very much data, but cameras can often create this congestion within the bandwidth that we're not ready to handle. So beware of how many bytes per second you can send. Make sure you're not confusing your bytes and your bits, and you'll be able to calculate kind of how much you can send in a certain period of time. Okay, so with that, the system considerations for cameras and soil moisture, one thing to consider is power. I kind of talked about it a little bit, but power consumption of the camera. If it's taking a picture, what's the resolution and what time of day are you doing that at? Using features like PTZ and IR, then you're going to have to configure your power draw to be able to sustain those operations. And those will be dictated by the application that you're trying to hit. Power consumption adds data with the added data. So you add more data, you transmit more bits. Your transmitter typically consumes one of the highest power consumptions on your device. And so if you're transmitting more often, you're using more power. So keep that in mind. It's not just the power of the camera. And as we talked about before, if you need that small detail for AI or ground truth, just kind of a general picture, that'll dictate what you're putting into your camera. Now, soil moisture, you need the power to actually take the measurement. So is there an excitation current that needs to be provided, or an excitation voltage that needs to be provided in order to take these? Is it always powered? Some devices need to have constant power and have a quiescent point, quiescent drain. So you'll need to know what the power drain is during on, and while it's off, is quote unquote off as well. Another ticket is the multi or single parameter or single sensors. So you have some probes that take more than just your soil moisture. They take salinity and others. There's also some probes like we saw that were multi or single sensors within the actual device. You're basically adding multiple sensors to the same device, so the current will be increased by the multi-sensor versus a single sensor, which makes good sense. And then one good thing to know here is just as it says here, I had one time where I was up on an install and we were working to figure out why a unit would not power on and stay powered on. Finally troubleshooted down to the sensor that they were using would often fail with a very high current draw. So it wasn't ideal. Come to find out, the sensor itself was prone to that type of failure. And so understanding how these sensors could potentially fail will allow you to not run your power system into the ground over a simple failure sensor. All right, so I breezed through that pretty quick, but that's all that I have. I don't know if there's any questions here for anybody.
We do have a couple questions.
Okay, great.
You'd like me to read them? So,
yeah.
First question, you sort of touched on this. Do you see the entrance of HD security cameras entering this market, or are these more sophisticated?
Yeah, so I do see HD security cameras entering the market. However, I also see the development taking that type of a camera and developing AI around it so that it becomes more of a station itself. People are making taking images of a simple staff gauge and then providing AI through software in order to determine what the water level height is at that location, and a bunch of other different parameters will be able to pull from AI when when these come about. But they're still being developed. I haven't seen anything that's really widespread yet, but that's kind of where I'm seeing that trend.
Cool. Next question, where do the signals from these devices typically go? Meaning, what is the user group or subscription service, municipality, or NOAA?
Okay, so for I guess that really depends on who's doing the question here. Flood districts would have them then go directly to their database. Others may have the, I guess that's a hard question for me to answer. There's each application kind of has their own desired, server service that they have out on the web. And that's kind of dictated by what software you want to run. And then once you have that, you can do, you can send this data to an FTP site, you can send it to directly to a server and have that server parse through data. You can have it sent to a web page and someone can pull that web page. Like there's so many different applications and every entity kind of operates differently. So yeah, I guess that's kind of, sorry, the answer is it really depends.
No, I think that's an acceptable answer because it does. We had cameras that the USGS installed here in Nashville for us years ago, and they went to the vendor's website. We had a login and password, and that's as far as it went because that's as far as we needed to go.
Yeah.
So.
Yep, and others would use an API to pull off of that vendor's site or something of that nature. So how far and how involved do you want to be?
Okay. Well, thank you for that. I don't see any more questions coming in.
Okay.
So
Okay.
We'll stop recording. And as a reminder to everyone, you will receive your hour of continuing education for CFM credit here shortly. And then we'll post the recording up on our YouTube channel as well. And then look out for the email for our next webinar at the end of June. I appreciate everyone's time, and see you next month.
Thank you.
Thanks, everyone.